everybody. Welcome to another coffee hour. My name is Paul Abernathy, your host. As always, thanks for joining me and taking the time out of your day to get into some electrical stuff. Grab your favorite blend of coffee, whatever it may be. My blend is good old coffee. What is it? Donut shop today. Just plain old donut shop. I even think it's a Costco brand or something. Maybe not. I don't know. It's whatever it is. It's good. So whatever you got going, maybe you're on the road, you're heading out to the job site, maybe you're looking at some drawings, some plans, you're thinking about how's my day going to go and all that good stuff. But I'm thankful you're here joining me today. And as always, if you've never been to Coffee Hour before, remember, it's not specifically designed to just be exam prep. It's here for you to come, let me know what's going on in your day, ask questions, interact, post something. Whether it's a poop emoji, that's fine. Okay, that's fine if that's how you feel. But at the end of the day, we're here to get together so we can just talk a little code, have an interaction, get your day started, maybe look at some lessons, maybe look at the NEC, maybe look at the Trade Hog, those type of things, just to get your day going. And so I appreciate you folks taking the time to join me. Now, the rule is you got to let me know where you're from. Let me know whether you're a fast track student or not. And let us know your name and wish us a good morning. It's a good morning. Okay, it's the February 11th. We're getting closer to the weekend. We just put it in our rearview mirror, but we're getting there. And here in Virginia, we are expecting snow. Hold on, I am not excited about snow. I got 3 little mountain feists, and as y'all know, we built the place here, and it is got nothing but mud everywhere. Can't get the grass to grow, it's nasty. It's gonna be nasty. Let's put it that way. All right, let's do some morning stuff here. Like I showed this during the prelude. Adam, good morning. And let the lesson begin. Uh-oh, folks, I can feel it coming. Oh, God, there it goes. Woo! All right. I'm allergic to myself. Good morning, Adam. Definitely going to let it come. Let the learning begin today. Damn, I'm allergic. I'm allergic to myself in my own place. That's not good. Let's see here. Good morning, everyone. How much snow did you get, David? 3 inches, but here, once again, we get nothing. So John's talking to David. David's talking about some snow. We're supposed to get, I think, 5 to 6 inches here in Central Virginia. God, I hope not. Nepo, thanks for joining and good morning. John in here for the win. We got Michael whatever. Mike, sorry. Solano, is that right? Mike Solano for the win. Hashtag win, guys, to get in on the spin. Christopher, welcome. Good morning. Frank's in the house. Good morning. David says, replying back to John, 5 to 7 inches. That's about what we got. 4. Christopher, good morning. Again, good morning. Let's see here. Tino hollering at us from down there in Houston, Texas. Tino, thanks for joining this morning. What do we got, David? Dave in Florida, ready for some dwelling calcs. First parts of the dwelling calcs today. We're going to go over the square footage requirements. We're going to go over small appliance, laundry, that first stage in today's episode, and answer any questions you may have. This is a 4-part series, so it's going to take us on to the end of the week. And we may finish early, but then we'll just look at some examples. Let's see here. Paul, got your email, got your message, Paul. Definitely we'll look into that, see about whether we want to do that or not, but thank you. What's up, Jonathan? Good morning. Thanks for joining. Cryptomania is in the house. Thanks for joining this morning. Red Dog is in the house. Red Dog, whoop, whoop. Ooh, we got 7 in rain coming. Jonathan's got some nasty stuff coming. We do too. So I hope it skips us. Edgar, good morning. Wow, got a lot of folks in here this morning. Eric, good morning, Eric. Callie, up early out in California. Let's see here. From the 501st. Good morning. Again, if I never did say it and you did serve, thank you for your service. And David says, I purchased a Fast Track Enhanced program 2 weeks ago. Really like the program and the Fast Tracks too. Excellent. A team, they go very well together, that type of thing. Absolutely. Thank you for that purchase. And there's Jay. Jay, welcome from Vegas. Out in Vegas, rolling the dice. That's what I'm talking about. All right, that's our mornings. If you're straggling in here this morning, let me know your name, where you're from. We appreciate you coming and joining. So what we're going to do today is we're going to be looking at the beginning stages of the single-family dwelling calculation. Now, if you're an electrician, you're seasoned, you're already out in the field, you probably are thinking, this is old hat. But there are probably situations where you didn't think about the fact that I'm just doing a calculation for a building just because I've done it before, right? I'm used to doing it. I'm not going to do a load calc. I'm just like, I've done it. And also in future episodes here on Coffee Hour, we're actually going to go over how to do existing dwelling calculations, which was supposed to be a webinar that I was doing back a while ago. Also, let me know if the audio is going okay, if you can hear me all right, because I did update software here at the last minute, which is against my normal rule to do, but I did do it. So let me know if you hear me okay. But one of the things is that we want to be able to show all those type of things. So we're definitely going to do all that here on Coffee Hour. So if you're new to Coffee Hour, you've never came before, we do all kinds of things and teach all kinds of things. And so this came from a request from a viewer who I said, folks, go to paulabernathy.com and submit things that you want. And a viewer said, Paul, can you go over single family dwellings for me? And I said, absolutely, I can. So that is what created today. Now, some of these images are going to look kind of familiar because I've used this same presentation many times before. But again, it's no sense in breaking up something that's working. You know what I'm saying? So that type of thing. So that's something we got. Nepo says, welcome, Mike. I also see you in your Manny. I also see you in there. Terrence, I also see you in there. Maybe a poster. We don't do posters on the wall, but you can get them made. There's a lot of places online that can get posters made. We don't do posters only because I don't think a lot of people would buy them, and I can't get involved in making something that I don't think people will buy a lot of. You know what I'm saying? But we did have the cheat sheets that go in your code book, and I don't know where they are. We'll see if we can't get them back on the website. But we did have some cheat sheets that were, 8x11s that you carry with you that a lot of people get laminated, things like that. But we don't have any posters. Let's see. What's up, Terrence? Thanks for joining. David says the audio sounds good. Appreciate it, David. Keeping track of that for me. Now, okay. So let's kind of go to the first steps of, and again, also, yes, definitely do the hashtag win in order to get in on a spin. You only need to do it once and you'll be in it for the day. But there you go, hashtag win, and that'll get you in for the spin. Okay, let's kind of go to the lesson first. Okay, you'll see me, my nose is running like crazy today. You'll see me up here. And so if you got a question, we will pop it on the screen and I'll try to answer the question for you. But we're gonna go with the very first parts of these calculations for single family dwellings today. Now, again, you might be asking, why are we doing a single family dwellings when most of the time you're probably going to do an optional method when you're out in the field? Yes, probably 99.9999% of the time you're going to definitely be doing an optional method. But when you're preparing for electrical exams and you need to do the neutral, other than just full sizing the thing, you need to know how to do the calculation, right? So the code is very clear that the neutral calculation is actually in part 3 of Article 220. So that means you can't use the optional to size the neutral, okay? So we have to be able to do a calculation, okay? So at the end of the day, you really do need to understand how to do the standard method, and it just makes you a better electrician. Dude, y'all have heard me all the time say this. Just because I don't have to do something doesn't mean that I shouldn't learn how to do it, because it just makes you a better, we're electricians, right? And some people are just happy with pulling home a paycheck. I get it, no disrespect. But I can't help but wanting to learn more and being detailed about it. I can't help it. It's just part of my nature, and a lot of you are like that. We just want to learn a little bit more. And so that's what we're going to try to do today. All right. All right. So let's kind of get over here. Okay. So where do we begin? When you're doing a calculation, especially for a load calculation, when it comes to a single family dwelling, of course, it's the same from other dwellings. You gotta have the start. You got to be able to pick the things. You got to know what's going to be incorporated in my calculation. So I tell people all the time, when it comes to even a single family dwelling, a lot of times the homeowners, the builders don't give us the information that we need, right? We don't have all of the stuff that we need, the nameplates from certain things like the dishwasher or whatnot. So it makes it a struggle, and I get it. On an exam, they're going to give you the information because, again, they've got to give you the stuff to be able to calculate it out. But in the real world, which we all are in, we have to ask those questions, and we have to ask the builder, we have to ask the owner, we have to stay engaged. It's very hard to do an estimate or do anything where they don't give you the information that's necessary to be able to do the work. Okay, so you got to be diligent about it. You got to ask about it because you need to have all that information, right? Now, in our situation, for our calculation that we're going to be doing this house, and this is the information that's been provided for us. Okay, so as you can see here, now we'll be focusing on the first part in today's episode. So today we're focusing on understanding square footage, understanding what's not included in square footage, understanding the small appliance brand circuits, the laundry brand circuit, that type of thing. We're going to be doing the first part of it, okay? And that allows us to set the foundation for where we get started, okay? So that's the thing. Now, as you see them on here, always assume that the water heater, the clothes dryers, the counter-mounted cooking, wall-mounted ovens, and electric heating is all KW ratings are equivalent to kVA. K being kilowatts, kVA being kilo, K being the kilo, 1,000, VA being volt amps. So if something is 10 kW, it is also 10 kVA, right? If it is 10,000 watts, then it is 10,000 VA, okay? So they're synonymous, if you will. And you should get used to that because what we try to do always is to resolve things into VA. I mean, that's our goal because that's going to be part of our calculation, and we want to get the VA at the end so we can divide that by the voltage, and then we know what we're sizing, right? So you may get a question that's given to you something in kW, and you're going to work it out individually, but at the end of the day, you want to make sure that you'll resolve it into a VA, okay? Also, when you start a calculation, maybe you're doing a dwelling, and we're not going to get to that today, I don't think, because we're not going to do the ranges, or we're doing the first part. This is a 4-part series if you're just joining in. We're doing this whole week because I was asked to do it, and I think it's a good topic. But in some cases, you have to do the math first, right? And so when you're looking at, for example, we will. I don't know if we'll get to the full appliances today, but when we're doing appliances, for example, if it's a 0.5 horsepower disposer, then we're going to have to utilize 430. We're going to have to find out what the FLC is for that in-sink waste disposer or garbage disposer. So work your math out first. I always tell people to do that. If you're doing it in the real world, work your math out, get all your appliances that they have a motor associated with them, or get all of the things that you've got to do, like heat versus air conditioning. Make sure you get all of that stuff and break it down to get your FLC and get your VA. Do that right away. Okay, does that make sense? We won't need to do that now, but we will do that as we go on into it. Also, want to do some shout outs again real quick for the morning. Good morning, Richard from Anaheim. Thanks for joining. Manny, we see you in the house. There you go, my Facebook friend. Mike, thanks for joining. Mike, absolutely, thanks for being here. Dan is going #win, getting in on the spin. And I see you, Samantha. Thank you for joining us from Hanford. I see you in there. So good morning. Now, what does Adam say on the screen real quick? It says, thanks for doing the replays. I watched them once. I get home and really understand all the questions you put during the coffee hour. And now I'm hearing Jeopardy turn while I fall asleep. All right. Well, I have no copyright infringement on the fact that the Jeopardy tune is playing in your head because I can't control that. that type of thing. What's up? We have, let's see here. David, thank you for joining. Okay, recommendation, consider doing a series on Article 240. Can do that. Just go and recommend it over on paulabernathy.com, and we will put it into the queue. If there's something specific in 240, it's pretty broad. If there's something specific in there, let me know. We'll try to tailor something for you. All recommendations need to go through paulabernathy.com, please, as that puts it in the right location. But I do remember it, so I will write that down. Gianna Carlo. I probably said that wrong. Good morning, Joey. Thank you for joining me as well. Okay, let's get into the lesson real quick. Okay, so this is what we're talking about. So we're going to be working on this first part today. Okay, we're going to be working on the dimensions. We're going to be working on the small appliance. We're going to be working on the laundry, those type of things. That's what we're going to be working on first. Okay. All right, so again, also remember that we tried to tailor this to multiple code references. So some of this may be the 2020. Some of this may be the 2023. I will point out which the best that I can if the link is working. And link has not been working this morning. I don't know. It's an NFPA thing. I don't know if they're working on it or something's being done to it or whatnot, but it is definitely not working this morning. So typical, I would probably say it's NFPA doing it on purpose for me at 8 a.m. in the morning. Probably would be a good assumption that they would do something like that. Knowing that my love-hate relationship with NFPA, I wouldn't put it past them for nothing. So we will use the 2020, if that one will load. And let's see if we can't get link reloaded. Hold on here, folks. Let me go in and log back again and see if it hasn't kicked me out. And let's see if 2023 will come up. Okay, we'll try to do it. Okay, it looks like it's loading now, so it isn't just me, okay? It isn't just me. All right, so I'm going to go to the code. Okay, and there's been some changes, and I want to talk about these changes so that you can see these changes, because I haven't changed it in this material because it kind of covers both 2020 and 2023. So as you look on the screen, what's the first thing we need to do? We need to think about dwelling units, and this says 220.14J, which was in the 2020 edition. In the 2023 edition, what we'll be looking at is 220.41, okay? So all that, those type of things. So again, it's a little different depending on what edition you're in, okay? So in this one, we're looking at a reference is under the 2020, and it's 220.14J. And basically it says the general lighting loads are determined, they require the minimum lighting load and general use receptacles per square foot of the floor area. So we're talking about that 3 VA per square foot. And again, it's in 220.14J if you're in the 2020. If you're in the 2023, it's 220.41, okay? And what we're talking about is 3 VA for dwelling per square foot. Now, you use the outside dimensions, okay, of the actual dwelling to do that, okay? And in our case, as you see on the screen, there is an open porch in that, okay? So if I were to go look at the code, just really quick, over here, okay? So we see 220.41. Now this is the 2023 version, okay? All right. And you'll see that it tells us the minimum lighting load shall be determined. Remembering it also is including the general use receptacles, okay? So don't let that throw you. It says the minimum lighting load shall be determined using the minimum load unit, which is 3 VA per square foot, and the floor area as determined in 220.5C. So that is a relocation change as well for the 2023 edition. So I'll click on it so you can see it. You see this little N right here, okay? That means it's new, been moved around a little bit. And in the 2023 edition, it says, for dwelling units, the calculated floor area shall not include open porches. Okay, we do have an open porch, okay? Or unfinished areas not adaptable for future use. as a habitable room or occupied space. Now, what's interesting here is that in the 2020, I'll take it back to me real quick. In the 2020 edition of this, it said garages, right? And in the 2023 edition, garages is removed. So that means that garage space would have to be incorporated in it, okay? So that's kind of a change for 2023, just to be aware of. And if you're studying for an electrical exam, you're studying whatever code cycle you're in. So some of this stuff you may see and you may not see. It just, again, depends on which code cycle you're in. So I tried to mix the two. And so later you'll see also some 23 and some 2020, trying to keep it so that I can flip back and forth. That was the intent of this. All right. So as you see, we have our values right here. And we have an outside dimension of 35 by 55. But there is the open porch, so that is 7 by 10, so that is 70 square feet. And because the open porches are not included in the total, that 70 is deducted from the 1925. And where do we get the 1925? Well, that's just 35 by 55, right? So if I'm doing that, I just do 35 times 55, okay? And there you go. So what I got to do is I've got to deduct that, okay? So you see in a calculator. Right there. So that's 1925. So I've got to take 70 away from that. And that gives me 1855, right? 1855. Of course, you can see that all right here on the screen, right here in the yellow. So that was 1925. And I take away the value for that open porch. And that gives me the 1855. And then that is what I multiply by the 3 VA per square foot. So the raw value for this dwelling is what? 5,565, right? Because I took the 1855 multiplied by 3 VA, and that's how I got it. So that is your general lighting and your general use receptacle loads. Now, on an exam, if we're talking exam, they might just ask you a question, what is the general lighting and general use load, right? Okay. So it didn't ask me to take anything. It didn't ask me after deductions. It didn't say anything like that. So some questions are just that simple. It wanted to know what the general lighting general use load is. So you want to look at the answers, obviously, to be able to focus on what they're asking you, that type of thing. They didn't ask for anything else. They haven't asked you any question about your small appliance. They haven't asked anything. Okay, so I mean, you have to be very hyper focused on the question. But my goal here is less about preparing you in the exam and more about preparing you how to do the steps, that type of thing. Russ says, you never notice that garage change, old habits die hard, I guess. Yep, always changing. Got to be aware of the changes, adapting, all those kind of things. It is what it is, but absolutely. All right, so let's go back to the lesson. Okay, so we got our first stage. That's our general use and general lighting. And oh, by the way, also people ask and say, where do you get the rule that says that it does cover your general use receptacles, like the receptacles that are in your bedroom, receptacles that are in your living room, that type of thing? Where do you get that into the NEC? Okay, well, in the 2023 edition of the NEC, you'll see that right here, it says unit loads include the following: lighting and receptacle outlets. No additional load calc shall be required. That's where you get it. And down here, it says all general use receptacle outlets of 20 ampere ratings or less. So that's your 15 amp, that's your 20 amp. Those are any of those that are general use, okay? And it includes receptacles connected to the circuit specified in 210.11c3, bathrooms, and garages, okay? So what does that mean for me and you? That basically means that in that 3 VA per square foot, you know that the code requires us to run that bathroom circuit to supply those receptacles that serve the countertop, the basin. That's already figured in the 3 VA per square foot. So that's just a circuit, branch circuit thing. We've already figured in that its loading is figured in the 3 VA. And the same for the garage receptacles, already figured in the 3 VA, okay? So already in there, that's for those general use things. Not specialty use, Not something that you know you're running a dedicated circuit to it. That's got to be included in your calculation. But we're not talking about that. We're talking about general use applications, okay? General use. All right. So just to check back here, okay, so these are taken care of right here. We got the first part done, easy peasy. Okay, next thing we got to tackle is those small appliance branch circuits. And if you remember, we had 4 of those to deal with. Now, interesting, if you look at the National Electrical Code in 220.52a, which we will go to, okay? If we go to 220.52 right here, you see A, all right, this is obviously in 220, okay? And just for craps and giggles, so you can see where we're at, okay? We're doing a load calculation, so we're in part 3 right here, okay? Part 3. All right, so this right here tells me small appliance, so we're just following along. It says that each dwelling unit, the load shall be calculated at 1500 VA, okay, for each 2-wire small appliance branch circuit as covered by 210.11c1. Now, 210.11c1 is referring to the minimum number. So it's telling us that there has to be 2 or more 20 amp small appliance branch circuits, okay, that is provided for all receptacle outlets specified in 210.52b. So that is your kitchen. That would cover the walls. That would cover your countertops. So can you have more than 2? Absolutely. But you have to have what? You have to have at least 2. Okay? And that goes the same for your load calculation, folks. All right? The load calculation you're doing, if you're on an exam question and they want you to do the, they give you this dwelling and they want to know what the small appliance, they want to know what the general use in general lighting and other after you have applied the demand factor. And if they don't tell you the number of small appliance branch circuit, then you're going to have to assume at least 2 at 1500 each. And you're going to see that we'll assume at least 1 laundry at 1500. But those are things you just have to know. So if they literally want you to do a load calculation on the first stage of like what we're doing today, then you have to be able to know that it's at least 2 and they're 1500 VA each to do that. Okay. Now we have 4 in ours. Okay. So remember that also. If you happen to have more than 2, then you have to account for them. You don't just stop at 2. If I got 4, I need 1500 VA for each. Okay. A lot of people do stop at that and think, well, it says only required to have 2. No. If I've got 4, I got to have 4. So as you can see what we looked at, so this is what gives you the VA, 1500. This one, 210.11c1, this gives you the at least 2, but we have 4. Okay, so since ours has 4, there's 1500 VA each, so it's 4 times 1500 VA, and that is 6,000. So that is our small appliance branch circuit load. Okay. So again, if they give you an exam question or they talk about something that is before any demands are applied, then the total value or what we would say the gross value is 6,000. The net value is going to be after we apply some demand to it. But the gross value on that is 6,000 because we have 4 of them. Make sense? If you got any questions, folks, put it down in the chat. I'll definitely make sure that we answer those questions for you. All right. Pretty easy peasy, straightforward. All right. And then we get to the laundry circuit. Now, the laundry circuit, we had 2 in this house. Not a very big house either, though. You know, this wasn't but a total overall 1,900 square foot, under 2,000, and they got 2 laundries. Probably not going to be what happens. But in this case, the question is irrelevant to real life. It is what it is. And in this question, we definitely have 2 laundry. Okay. So let's see here. So Frank asks there, so the bidet. So if you have a receptacle and you run to, remember the circuits for the bathroom are already incorporated into the 3 VA per square foot. If I'm installing a bidet and it's a dedicated circuit to that bidet, because that cannot be on the circuit that's run to serve the countertop, okay? That can't be on that circuit that's within 3 feet of the basin. So if I'm running, now that doesn't mean that I can't put that receptacle on another circuit. or depending on the size or the load demands for it, it may require a dedicated circuit. So it would be no different in adding that receptacle load into your overall calculation. But again, usually the bidet or something like that is going to be pulling a very small amount of current that typically you would add that onto another circuit that would be there, maybe off of the bedroom or something like that, with keeping in mind that you got to be hypersensitive on the actual load that it would pull. Of course, it's got to be GFCI protected, but I would tend to say if it's just a standard receptacle that's there to run a bidet and it's not something that the manufacturer required a dedicated circuit to, or an individual brand circuit to, then I would probably just incorporate it in the 3 VA per square foot. I probably wouldn't do anything additional for that. But if you have, and be honest with you, never put a receptacle in for a bidet, so I don't know. A bidet may have a higher amp value. And if that's the case, then we have to be aware of certain things like cord and plug connections and loads and things like that we have to worry about, okay? So that's how I would address that. But if I have a bigger load that's a individual brand circuit too, then we have to incorporate that in, and that would not be a part of the 3 VA per square foot because that's general use receptacles. So again, in the scheme of life, I probably wouldn't do anything different for the bidet receptacle. I wouldn't, unless it's something special and it's a seriously high amp draw bidet. Not a question you'll get on an exam, by the way, but that is a real world type question. So thanks, Frank. That's how I would address it. I would look at what the bidet is going to pull. And if it's pulling hardly anything, I just would put that part of the circuit that's there. Not the one serving the countertop. I would just put it on with the lighting maybe, or I would put it on with the bedroom or whatever system or the hall, whatever's near it. I'd probably put it on with that if it's not going to pull that much current. All right, so where are we at? And I wouldn't add any VA personally. Let's see here. Laundry again. So again, under laundry, we can go look at the code for that. All right. So that is down here. So that is under 220.52, and that's B right here. Right here. All right. And this is telling us here, it says a load of not less than 1,500 VA shall be included for each 2-wire laundry brand circuit, as covered by, again, 210.11C2. That talks about the laundry. So we're going to do 1,500 VA for each one of those as well, okay? But you have to have at least one in this dwelling unit. But we've got 2 of them. So obviously, as we know, we're going to count for 2. So 2 times 1,500 VA, that's 3,000. So our gross value for our laundry is going to be 3,000 before any adjustments or corrections or any type of demands are applied to it or allowances. So that's 3,000 before we do anything. Okay. Just be aware that you could get a question asked like that on an exam, wanting to know what was the laundry brand circuit. And that brings us to me an important thing. Hold on. Let me bring this. This is important. There is a difference between connected load and calculated load. Okay. So if they ask you a question and they want to know what the connected load, that is just the pure value of it being connected, right? And then the calculated load would be the load after applying some time of demand factor to that. So in our laundry, it's 3,000 VA is the connected load, and whatever the demand applies to it in our calculation would result in a calculated load. Does that make sense? So that's kind of one of those things on a question to look and see whether they're asking you for the connected load, purely connected, no demands have been applied, and then calculated load means it's implying that something has to be calculated. That type of scenario. All right, so there's our 2 that we're required for our dwelling that we're working on. Okay, so that's 3,000. Okay, now what we have to do now is we have to bring all that together. And here you see I'll start incorporating both 2020 and 23 because now it's getting to where I want to make sure we really are focusing it out. So now let's bring the lighting and the receptacle loads. That would include the general use. That's under the 3 VA. The general lighting, that's under the 3 VA. Okay. And that would be also, by the way, the general lighting that falls under 210.70, all that requirements for the lighting, that's all general use type of thing. Now, can I have some lighting in a dwelling that is maybe not general use? Maybe some dedicated lighting, maybe some real fancy, sophisticated lighting, something extra. yes, that would not fall under general lighting, and I have to take it into consideration. And you may or may not be able to apply demands to it. You may not. You might have to take it at full value if it's some kind of specialty lighting that wouldn't fall under the general lighting. Now, on an exam, not going to be what you're going to get. I mean, you're going to get a pretty straightforward question about general lighting, general use, that type of thing. But in the real world, just keeping in mind that some things may fall outside of a general use application, like a dedicated branch circuit or individual branch circuit, as we call it today, that has a specific load that has to be accounted for, okay? That might not fall under the general use application. So you just have to be aware of that, okay? What does Nepo say? Nepo says, I was just watching your series on this on Fast Tracks Tube yesterday. Very useful for us industrial hacks. Well, you know, it's one of those things that if for folks that aren't familiar with dwelling and stuff, they always go, dwellings are easy. Everybody always goes. I used to have people that'll go, I'm a commercial electrician. They're much more they're much more in tune than the residential. And I always tell people, residential can get quite complicated. If you think about some of the houses, I used to do multi-million-dollar houses, and the amount of stuff that people want in their house get quite complicated. All right, so we pull everything together. So remember, we had 5,565. That was our general lighting, general use. That was the 3 VA per square foot. Remember, we did that, and we did that value. We took away the open porch, which is 70 square feet, and we multiply that by 3 because it's 3 VA per square foot. That's where we got the 5,565. You remember how we got the small appliance? That was 6,000 because we had 4 1,500 VA small appliance branch circuits. And then the laundry, remember, we had 2. And they were 1,500 VA each, okay? And we got all that information from where? 220.52A and B, okay? And so that's all right. So we simply add those up. Now, before we can apply any demand factors, we need to know how those demand factors are going to be applied. Now, in Part 3 of Article 220, the standard method is calculated, and you're going to see in 220.42 is this one right here. This right here. This is your 2020, okay, and 2017. And it changed in the 2023 edition of the NEC. It moved to 220.45. So for you that go looking in your 2020 and go, whoa, wait a minute, something doesn't look right to what Paul's jiving with. It did get moved, okay? And the general lighting, we get permission to use 220.42 or a table 220.45 where applicable, okay? So we get that permission. So let's kind of go over and see where we get that. Let's see here. Let's go over to where we get that. All right, here. So here's 220.45. You see that this is grayed out, so that's been moved, okay? And it says the demand factors specified in table 220.45 shall apply to the portion of the total branch circuit load calculated for general illumination, okay? They shall not be applied to determine the number of branch circuits for general illumination. Okay, so this is not, you're going to use your branch circuit loading calculation to determine the number of branch circuits you need. This is not what this is for. This is for your load calculation for the service. Okay, so we get a little bit of diversity when we're doing a load type of application, okay? All right, so let's see here. So here's the table. So let me take you back real quick. So we're going to be able to apply some of our diversity here. See if the table blows up here, if we can see it. Okay, here it is. Okay, so again, what I like to tell people so they don't get totally confused is even though this might say portion of lighting load to which the demand factors applies, you need to understand that this does include the general use receptacles, okay? So again, a lot of people want to see that wording in there, but it does because we got that permission earlier in our load calculation. You saw that, right? When we did the general lighting and general use, it stated it's already considered in there. So here, since we're doing dwelling unit, it's telling us that the first 3,000 is going to be at 100%. So that basically means you take 3,000 and you set it aside. So whatever your total is, you're going to set it aside. And then we always say the next 117,000, but basically it's 120,000 minus the 3. So it's 3,001 to 120. But you'll hear me say, once you get past the first 3, the next 117,000 which is the value over 3,000 all the way up to 120,000, that's at 35%. And then anything over that 120 and up, that's going to be over 120, is going to be 25%. Okay, so y'all have heard me say that before. So I just want to make sure that we're clear as we move forward, and this is what we're going to use. Now, again, if you're in the 2020, you're going to be using 220.42, but we're in the 2023, so we're going to be looking at 220.45. Okay, so here's where we bring all of our goodness together, and I've got the code references right here on the screen, and we give you both, okay? So you've got, now let's bring the general lighting and receptacle loads, and that includes the general use as well as the small appliance and laundry loads, okay, together so that we can apply some demand factors here. So there's our numbers from before. And this is our nifty table from the code. Here it is depending on which code cycle you're in, okay? Do the math. Double check my math, folks. Sometimes I put things in a certain way to test you. 5565 plus 6,000 plus 3,000 should be 14,565. I'm going to check myself. So I'm going to go 5565 plus 6,000 plus 3,000. And that is 14,565. So that is correct. Okay. Let's see here. What do we got? Adam, I'm so glad I printed out templates for this. So helpful. Thanks. Again, remember in our Fast Tracks program, guys, we do have a form that you can print out that walks you through these steps, and it tries to teach you. So if you're not in our Fast Tracks program, you can't get these forms. But if you're in our program, these forms are available for you to download and utilize. Okay. Now let's see here. Let me go back here. Let me answer some questions real quick. Van Man says, can you get the area of a conductor from chapter 9 table? So no, we're trying to get the area. We're going to, for conductors, we go to the different areas. It's chapter 9 tables. I believe it's 5. Okay. Might be wrong. Let's go real quick. I want to make sure I answer these questions. We'll come back. It's 4 or 5, but let's show because it did get the question. So here's chapter 9, and we want to get the conductor properties. So we're going to go down. Let's see here. This table. Hold on here. I think it's maybe 4. Hold on. Okay. I got to be careful because sometimes this stuff doesn't want to work right. Here we go. All right. So this is dimensions. Let me pop this up on the screen. Okay. So what you're doing for your conductors, you're coming over and you're looking for the approximate area. And so table 5. Yeah, I was right. Table 5. Table 4, by the way, is, and let me pop this. Actually, let me do it. Hold on here. There you go. So table 4, by the way, is the dimensions of percentage fill for each type of raceway. God dang it. I'm not sharing the screen, so how can you see what I'm talking about? All right, so right here, table 4, that's for your fill. And a conductor like THHN and all that kind of stuff, you're coming down here and you're going to be looking at these, which is table 5. And this is going to give you your approximate area. Okay, and you're going to be wanting to use right here, the square inch value right here. Okay, that's what you're going to be using. So that's insulated conductors. For the individual conductors, you want to be going to conductor properties. Okay, and that is going to be table 8. And this is where you get your circular mill area for the conductors right here. Okay, and you're okay until you get it from 25 to 250 kc mil is exactly how it sounds. But when you're 4/0 and less, then you're going to need to come here to find out what the circular mill area is. Okay, so that's what you're going to be. So you'll be using table 8 for that, and you'll be using table 5 if you're looking for raceway fill, for example, and you're using insulated conductors. Hopefully that answers your question. I like to make sure I catch the questions before I get too far into this. Okay, let me go back to where I was. Sorry about that. I see a question. I want to make sure I answer it. I don't want anybody to go without having any questions if I can help it. Okay, so that's what we're working on, right? So that's what we'll see on our screen. These are the values we'll be using. And this is table 220.45 if you're in the 2023. And that's where we're at, okay? All right, so here's what we're doing. So we did this, so we're adding all these up. So we took that's 14,565. Okay. Now remember, it said the first 3,000 at 100%. Well, so basically, we're taking that 14 and we're going to take 3 away from it, and that leaves us 11,565. We're still going to use this 3. We're just kind of setting aside, right? We're just placing it to the side a little bit, right? And so then we go, and so we say from 3,001 up to 120,000, or as I like to say, up to the next 117,000. Then we take that 11,565, we multiply that by 35%, 0.35 if you're using a calculator like that, and that gives us what? 4,047.75. Now, I'm not going to trust my math. I'm going to get the calculator just like you should be doing. Do this, and I'm going to do this times 0.35. And that is exactly right, 4,047.75. Okay, now 0.7, I'm going to round that because I get the permission to round that in the code. Okay, and we get that in 220.5. If you don't know where that is, I'll show you. So here is in the code. We'll go back here, calculations, right here. Okay, it says calculations, and only dealing with amperes now. We're dealing with amps. Difference between watts and dealing with amps, okay? It says calculations shall be permitted to be rounded to the nearest whole number with the decimal fraction smaller than 0.5 being dropped. So we're able to do what? 0.5 and greater, we round up when it comes to amps. Okay, this is amps. Amps, amps, amps. Okay? Big difference from kW and VA. We're talking amps. Now, ultimately, with volt amperes, you can round and you'll get to the same goal. But just want you to be aware that when we're doing that, we're talking amp rounding, okay? And so that's what we're doing here. And VA is volt amperes. So we're able to utilize the rounding in the VA. That's why we like to get everything from kWs, try to work them down into VA so we can do the rounding. All right, now, if you wanted to take the full value just for craps and giggles, you could. At the end, you'll be rounding anyway. But it's better going and get it rounded off at the beginning. Okay, so it becomes 4,048. Plus, we got to do what? We got to take back that original 3,000 VA, right? We have to take it back, okay? And so we bring that back. So that ends up being 7,047.75, okay? If we did not round, right? So I could take this number or I could round it and it would ultimately achieve the same thing. See? So you know which step you're doing. So if we just took the 7,047.75, it's still 0.75. Ultimately, it's going to be 7,048. Okay? So that is our general lighting and receptacle loads. Okay? Not just general use. Okay? That is our general lighting and receptacle loads, including the lighting, general use receptacles, and the receptacle loads from our small appliance and our laundry, all wrapped into one, okay? So, there you go. Let's see here. What questions do we have? Any other ones that we've got in here? Let's see real quickly, because that's pretty straightforward. Oh, what we got to do is we got to do some giveaways. So let's go to the contest real quick. Let's do some giveaways, or let's get you on the list. So make sure you hit #win to get in the drawing. Okay. Ooh, look, I'm even in there. If I win, everybody wins something. All right. I shouldn't have said that. I'll take that back. All right. So if I win, we'll just spin again. I'm nice, but I'm not that nice. All right, so let's go here. Let's see what we got, and I will do some music. Wow. Wow. I can hear Paul now. Dude, spin it again. What are the odds? I can't even, you know what? I can't make that happen. What's your question, Paul? Let me know. Now, let's see if we can answer it. All right, Manny Sanchez. Manny, let me get you on the list real quick, Manny. Let me get you on the list and we'll spin and see what we're going to give you or what we're going to get you registered for. Hold on here. Manny Sanchez. Okay, Manny, let's see what we're going to get for you today. Oops. Sorry, Manny. That wasn't good. That wasn't nice. That wasn't nice for you. We're also going to look at Trade Hog and test it here. Hey, Manny Sanchez, you want a minimalist wallet. So all you got to do is go over to our website. We pick the color. You don't get to pick the color. Find a design you want, whether it's a journeyman or master one. Email us your mailing information and everything, and which one you're interested in, and we'll get that done and get it out to you. Please allow a couple weeks for delivery, as I am backlogged with engraving, but we will get that out to you, Manny. So, okay, let's spin it again. And Paul, your question, remember it's crap in, crap out when we're going to try it on Trade Hog. So make sure you look at your question and make sure it's written accurate and not just a bunch of garbled words, because again, we have to look at it. But I probably will not answer it here for me because I'm 5 minutes away from ending and I still got 2 pieces into the segment. So probably should have bought that early on. But you can also go to paulabernathy.com and submit your question as well. But we will load it into the hog and see if we can get that. But again, a little bit late in the show for that, my friends. So let's do a spin here. Probably should have done that earlier, Paul. All right, David, we're going to spin the wheel, see what you can get. We still have the estimating software, the estimating course, a bunch of our courses on there, and Fast Tracks Tube, all that kind of good stuff on there. Look at the double, David. Listen here, David. Have you won a Fast Tracks Tube already? Let me look and see, because I've got the list here. David, see if you're already won that. No, you're in the drawing for an ohms wheel. Yes, you have won Fast Tracks Tube before. So we'll spin again for you. You've already won that before. See, I'm already on it, keeping track of, folks. I'll take care of you. You just increase your chances for that. So let's put you on here. Okay, so you've got multiple chances to win in that. So that's good. All right. Okay, so let's see here. Let's take, I don't know if I can here. Let me take Paul's question and we'll go and throw it into the hog, even as raw as it is. We'll see what the hog has to say. And Paul, you should have tried the hog. Okay, so we'll paste this in there and let me see if I can get rid of your name so that doesn't inhibit the hog. And I don't know how it's worded, but let's see what it says. See what the hog has to say. Good test for the hog here. Wow, a lot of info. All right, let's see here. It says, to determine which of the options for a higher class motor overload relay may preclude the need for, we must analyze the function and application of motor overload relays in accordance with the National Electrical Code and other relevant standards. Wow. Okay, got pretty deep there. Motor overload relays are designed to protect motors from overheating due to overload condition. They are typically a part of the motor control circuit and can be adjusted to trip at specific current levels to protect the motor. A shunt is typically used to measure current by providing a low resistance path. The use of a higher class motor overload relay does not directly relate to the need for a shunt. Separate terminal enclosure. A separate terminal enclosure is used for housing electrical connections. The use of a higher class motor overload relay does not inherently eliminate the need for a separate terminal enclosure, as this is more related to installation practices and environmental protection. All right. Example 20 NEC 110.28. That is the different types of enclosures, by the way. Selection of a higher trip current. It says a higher class motor overload relay may allow for more precise or higher current settings, potentially reducing the need to select a higher trip current setting manually. However, this is more about the capability of the relay rather than eliminating the need for the specific setting. Wow, that's a lot of information from the hog. Separate control circuit. A higher class motor relay, overload relay, may integrate more advanced control features, potentially reducing the need for a separate controller circuit. This is because advanced relays can incorporate multiple functions, including control and protection, within a single device. Based on this analysis, the most likely option that a higher class motor overload relay may preclude the need is for a separate control circuit, as advanced relays can integrate control functions that might otherwise require separate circuitry. Code references 430.32a1 in the 2023 specifies the requirements for motor overload protection. We've done that before. We know that 430.32 is all about the overload. Okay. So I'm at least happy that it brought the reference up. It says, which includes the use of an overload relay. While this section does not directly address the elimination of a separate component, it provides the context for understanding the role of the overload protection in the circuit. This response has been verified against the NEC and relevant standards, ensuring compliance with the stricter code requirements. Okay, so the question was, use of a higher class motor overload relay may preclude the need for which of the following? A shunt, a separate terminal enclosure, selection of a higher trip current, a separate control circuit. So it seems to me that a higher class may integrate more advanced. So let's see here. So it says, the best analysis, the most likely option, that is the higher class motor overload relay may preclude the need for a separate control circuit. Okay. So here it says for a separate control circuit. So it looks like it's choosing that one as the answer. Now, I will go back and research that. We'll bring it back in another show, but I really haven't looked at it. I have to go look that up and see that. But you got all the code references there, that type of thing. Okay. So anyway, what we did want to do is I did want to go test the hog with the question of the day as well. That was a lot of information. Seems like, again, separate control circuit. It seems like that would be the answer for that one, Paul, but I'll look it up. I'll look in detail. I'll test the hog. But let's look at this one and compare it. So we're testing out the hog. So this was the answer from Nika. Okay, this is from Charlie. Okay, and gives all these references here. So let's see how the hog works. Okay, let's clear this out and get a new one. All right, and let's go on and ask the hog. See what the hog. No comments, Paul. Did you get anything from that one? All right, what has the hog brought back? A lot. The hog brought back on that question, it says in compliance with the NEC, UFER. I like how it gave UFER and it says concrete encased electrode. So it's recognizing the information. That's what's interesting about the hog. Also, we've already started accepting the monthly memberships for the hog, and we've got people that have already signed up. We appreciate all of you that are jumping in and using the hog to a much deeper detail. We appreciate it. All right, so number one, compliance. It says, according to NEC 250.64c, the grounding electric conductor must be continuous or connected using irreversible splicing methods, okay, or CAD welding. The GEC should be run from the UFER to the main service disconnecting means, which in this case is a meter main located outside the dwelling. Connection point. The GEC should be connected to the grounding bus bar within the meter main enclosure. This ensures that the grounding system is bonded to the at the service equipment, which is the first point of disconnecting as required in 250.24a1. Okay. Routing of the GEC. The GEC must be routed in a manner that protects it from physical damage. If it's run through the building, it should be installed in a raceway or conduit per 250.64b. And I will remind you, make that PVC or you're going to have a lot more problems than you want. Okay. Now you can ask it deeper detail like item 3. Can you go into more detail? It'll do that. UFER. A UFER ground being a concrete encased electrode is recognized under 250.52a3. And it must be utilized as part of the grounding electrode system. If it is there, it must be utilized. So verification, this is a new feature that we put in here. It's cross-referencing itself. It says ensure that all the connections are secure and that the GEC is bonded to the grounding electrode system without any breaks. Okay, that is 250.64c. Cross-reference. It says some local jurisdictions may have additional requirements. Again, some jurisdictions can add some extra baggage to the requirement, but there you go. So now if we compare that to what Nika said, it says it depends on some details, right? So there was very little detail was brought. It did say if the concrete encased electrode is the only electrode serving the dwelling unit, says then the grounding electric conductor must be connected to the service disconnect in accordance with 250.24a1. So that was correct. We were there. The hog was right. Then it says if the concrete encased electrode is a supplemental. Okay, so this went into more detail. And so what you can do, just to show you, is that we can add this and say, what if the UFER is a supplemental? I don't know why it would be, but for some reason. All right, just asking if it was some. Hold on a second. Then it says, where would it be connected? All right, so just asking some more questions. Let's see what the hog has to say. Wow. Okay. The hog gave a bunch of additional information. So primary grounding electrode system. First, identify the primary electrode. That's so important because we made a question about it being the supplemental. It said verify that first. This could be a ground rod. This could be metal underground piping system or another NEC recognized grounding electrode per 250.52a. Supplemental electrode requirements. According to the NEC 250.53d2, it says if a single grounding electrode does not have resistance to ground 25 ohms, okay, or less, a supplemental electrode is required. The UFER can serve as that supplemental electrode. So this would be an example where, and again, you're supposed to go to these code references. That would be like, for example, if we're using a ground rod or a pipe or a plate, and it requires it to be supplemented, right? Well, then I could use a UFER to supplement that, right? Now, it says the connection to the system. It says the UFER as a supplemental electrode, which is what we ask, should be bonded to the primary grounding electrode system. This is typically done by connecting the grounding electrode conductor from the UFER to the grounding electrode conductor of the primary electrode system. This connection ensures that all the electrodes function as a single grounding electrode system. And then it goes on and tells you the bonding locations where you do that at. And again, it reminds you of protection, right? And then it cross-references it, okay? And then I could ask it, is there a list of locations that I can connect to per the NEC? I'm just throwing questions in there. I'm gonna be running out here in a minute of the number of questions I can ask. I'm just asking the hog different questions, and you should do that too. You should be playing with the hog and seeing what actually comes. Wow, okay, coming back with a lot of information. It says yes, specifies locations, okay, and it's going to break them down. Here you go. The service equipment enclosure, it's breaking each one of them down. the grounding conductor at the service, the grounding electroconductor bus, okay? Talks about jumper, meter enclosure, if permitted by the utility, okay? And again, the grounding conductor can be connected on the supply side. That would be 250.142. And so it's giving you, so as you can see, as much as you want to ask the hog will dig down deeper, deeper and deeper and deeper and deeper, that type of thing, okay? All right, let's give away something else, okay? And see what we got here. And then we'll end today's lesson. We'll pick up part 2 tomorrow, which will go over the appliances for a single family dwelling. And that's when we'll talk about things like the EVs and charging. All right, Dan Martins, you get to spin the wheel. See what you get. Let's see here. This tune will be going in your head forever. What does Adam say? Adam says, Fast Tracks Tube is the bomb. Yeah, our video platform is the bomb. It is a neat, and it's all ours. We've had it designed for us. It's very different than YouTube. Very different. All right, Dan, you're in the drawing for a voltage drop card. The new ones, the new little harder ones. Not the little flimsy ones. These are the harder ones. All right, you're in it. All right, and let's go on and do it again because I'm feeling generous. Let's give away another one. Hashtag win. Robert, I see you in there. Thanks for joining. I think of Tim Allen every time I see that. Outdoors, man. Okay. All right. Let's see what you get. Spin it. Spin the wheel of goodness. Got a bunch of stuff on that wheel. Haven't put that many people. I'm gonna have to increase the numbers on here when it comes to the software. We got to get more people registered for that software. Now, the people that are already registered say no, because it increases their chance. All right, outdoors, man, speak of the devil when it comes to Fast Tracks Tube. I don't know if you already have that. I'm looking really quickly to see, because I like to spin again for those that don't have it, or that have it, so that way they don't win it again if they don't want it. Some people have chose to keep it and get an additional year. We'll stack it for you if you want. But outdoor, I don't see anything on here for you, my friends. So there you go. So in order to get your free annual subscription, you just go to fasttrackstube.com and you need to sign up for a free membership and then reach out to us via email and let us know your information. And we, okay. You already have it or you got it now? I don't know if that, I'm not sure. Do you have it? Did you just win or did you already have it? Do you want to spin again? Gotta make sure. Gotta make sure you already have it, or you thanking me that you won it, and just make sure you go to Fast Tracks Tube and do that type of thing. I can't. I'm not sure. Now I have it. Do you have it? Do you have it? Have it? Okay, Alex. Okay. Okay. All right, Alex. Did you win it, or did you already have it? Anyway, let us know, Alex, and we will definitely get you hooked up on that. All right, everybody. Went a little over today, as I always do. That's why Adam says always bring a pint of coffee, because you never know. I never make it through a show with a full cup of coffee. But hopefully you got something out of today. So join us tomorrow where we will go over this second part of this a 4-part series, okay? Is that we will be talking about the small appliances and how they do that. And we'll talk about utilization equipment, standardization, how we apply demand factors to that, and all that kind of stuff. So that's going to be tomorrow's episode. That'll be part 2. And it's going to piggyback right on today's episode, which was part 1. Okay. All right. So hopefully that answered those questions for all of you. There you go. Okay, Outdoor Man. All you got to do is just go to fasttrackstube.com, sign up for a free membership, and it'll be elevated up to the annual membership. I promise you, folks, you cannot go wrong. Also, for those that are interested in really playing with the hog, let me show you real quick. If you're interested, and you're going to be limited, by the way, to how many times you can play with it, okay? We do limit it, and this number will decrease, but you can join the hog by going right up here and clicking on that little thing, and you'll come down here into pricing right here, and you can see that you've got two choices. You got $19.95 or $29.95. By vast majority, the people are going with the basic plan because it basically gives you 25 inquiries per hour, and most people will not go beyond that. But if you're a heavy user, then the premium is the one for you. And also part of that, you get access to our forums. And in our forums, you're able to post things. We do have a new mobile app that's available just for the premium members. And again, you would go down here where it says announcements, click on it for those that are interested. And you'll see down here, it says mobile app right here. You click on that and you'll see that there is instructions down here on how to get the mobile app, that type of thing. Okay. But remember, there's your pricing right there for those that want to help. We appreciate it. It's a monthly. You can cancel at any time on your own. But anyway, that's how you get, if you are in the limitations of the hog and you get a notice down here, then that's how you can get the hog. And then you can just use it anywhere and you can get the mobile app. It makes it so easy to do that. I'll even show you that just real quick. Just real quick. Come on, dude. I'm trying to make a living here. All right. So let me get into my phone. So you got your phone and you would download the mobile app and you scroll over on your phone when you download it and it will put him on your phone. You can see him down there. He's the bottom one, the third one, and you click it. And it'll load up like that. And it brings you there. And then you click the middle belly button and that'll bring up all these little features you've got. The forum, the Ask Paul, the login to get into your account, even a link to get to our video platform, which is there you go. Is that not the sexiest looking platform ever? Now look, I can turn the lights out so it dims everything, okay? And then you can turn it onto the side and go up here and you can do full view. There you go. Boom. There is no better player than that. So if anybody's had a chance to play with our Fast Tracks Tube, you're going to be amazed. It is the best video player out there, and it's getting better. We're going to add all of these coffee hours there, exclusive, and you'll see them slowly disappearing over on our free platforms. I know. Folks hate it. It is what it is. Okay. All right, everybody. Hey, I appreciate you. Join us tomorrow. We'll go into part 2. Till then, take care. God bless. And thanks for joining me today. Now get out there, make some money, and be safe.